Hi guys, and welcome back to another video. For this video, we will be going over positive and negative exponents, and as you can see on the picture to the left is an image that we will go over in more depth later, but it shows all the necessary components that we need for what we will be going over in this video. So the agenda for this video is first we'll go over vocabulary as always, then how to find a positive exponent, then how to find negative exponents, and then finally zero as an exponent. So for vocabulary, first we have reciprocal, which is the flipped version of a number, which may not seem like we need it right now, but we will need it for solving negative exponents, as we will see when we get there. So flipped version of a number, as you can see here, the reciprocal of 2 is 1 over 2, because if you were to write 2 as a fraction, it'd be 2 over 1, and then you flip it, so the 1 would go here, and the 2 would go here, and the reciprocal of 2 would be 1 over 2. Next, the base number, or the number getting multiplied when using an exponent. So remember that diagram? Here, it showed the base, and then here was the exponent, right? So the base number is the number getting multiplied when using an exponent, right? And now the exponent is how many times the base number is being used as a factor, or how many times you're multiplying the base number by itself. So if the base number is 4 and the exponent is 3, then we would be multiplying 4 3 times. So it'd be 4 times 4 times 4, and as you can see, 3 times. So how to solve for an exponent. So recap what an exponent tells us. So it lets us know how many times we multiply the base number. So how do we solve it? Just multiply out the base number as many times as the exponent tells us to do. Basic positive exponents are really simple. So if we have 4 over 2, it equals 4 times 4, since we're multiplying the base number as many times as the exponent tells us. So 4 times 4 2 times, and then when we solve 4 times 4, we get 16. So 4, and the way we say it is, like, we just say the base number to the power of the exponent, right? So in this case, it would be 4 to the power of 2. So in this case, 4 to the power of 2 equals 16, because 4 times 4 is 16. So now you guys can pause the video and just try to solve these pretty simple problems. Okay, so hopefully pause the video and solve, because I'll now be solving them. So 5 to the power of 2 would just be 5 times 5, since we're multiplying the base number the amount of times the exponent tells us, so in this case 2, and we would get 25. Next we have 2 to the power of 4, so it'd be 2 times 2 times 2 times 2. So when we do this, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so 2 to the power of 4 equals 16. Next is 3 to the power of 3, so 3 times 3 times 3. So when you do this, 3 times 3 is 9, 9 times 3 is 27, so 3 to the power of 3 equals 27. Next we have 7 to the power of 2, so it would just be 7 times 7, and we would get 49. So 7 to the power of 2 equals 49. Next we have 4 to the power of 4, so we would do 4 times 4 times 4 times 4. So 4 times 4 is 16, 16 times 4 is 64, then 64 times 4 is 256. And finally 12 to the power of 2, so we do 12 times 12, and we would get 144. So 12 to the power of 2 is 144. Okay, now we'll be moving on to how to solve for a negative exponent. So recap is what is a reciprocal? So it's a flipped version of a number. So 1 over 3 would become 3 over 1, which when we simplify, we would get 3. So 1 over 3, the reciprocal would be 3. So how do we solve for a negative exponent? So instead of multiplying the base number the amount of times the negative exponent tells us to, we're going to multiply the reciprocal of the base number the amount of times the positive version of the exponent tells us. So in this case, we have negative 3 to the power of negative 2 right? So it doesn't matter if the base number is negative, it won't change anything. So we know the reciprocal of -3 is not 1 over 3, but -1 over 3, right? So we would multiply that by -1 over 3 again, and we would get positive 1 over 9, since in this case you can see the negatives cancel out. And we can see that we multiplied it the amount of times the positive version of the exponent tells us, and in this case the positive version of -2 would be 2. So we multiply -1 over 3 2 times, and we got 1 over 9. Okay, so using that method, you guys can pause the video and solve these 4 practice problems. Okay, so hopefully you guys pause the video and solve, because I'll now be going over how to solve them. So we have 2 to the power of -2. So first, what is the reciprocal of 2? Well, as we know, when we write 2 out as a fraction, it would be 2 over 1. So then the reciprocal would be 1 over 2. So now, if we were to do 1 over 2 times 1 over 2, since the positive version of -2 is 2, we would get 1 over 4 as the answer. So 2 to the power of -2 is 1 over 4. Next, we have 5 to the power of -2. So what's the reciprocal for 5? Well, 5 over 1, we would simplify that into 1 over 5. Not simplify, just be the reciprocal. Alright, so then if we were to have the exponent as -2, that means that the positive version of it is 2. So we would multiply 1 over 5 times 1 over 5 twice, and then we would get 1 over 25. So 5 to the power of -2 is 1 over 25. Next, we have 9 to the power of -3. So what's the reciprocal for 9? Well, the reciprocal of 9 is 1 over 9, as we can see. And so now we're going to multiply 1 over 9 3 times, since the positive version of -3 is 3. And then we would get, I think it's 729, yeah, 1 over 729. And now finally we have 8 to the power of -2. So what's the reciprocal of 8? Well, at this point we can kind of see a pattern that it's just going to be 1 over 8. But I'll write it out just to make it easier for you guys to visualize. So we would be multiplying 1 over 8 2 times, since the positive version of -2 is 2. And we would get 1 over 64. Okay, well, we finished these practice problems. We'll now be going over the 0 as an exponent. Okay, so a normal exponent, so for a normal exponent, we know we need to multiply the base number by as many times as the exponent says. So if the exponent is 0, does that mean we multiply the base number 0 times? Well, technically that's true, but for 0 as an exponent, let's consider this. So if we multiply it 0 times, will the answer to 0 as an exponent be 0, since technically we have no value? Well, no. Any base number with the exponent of 0 will be equal to 1, not 0. And there's no practice problems for this section because all the answers would be 1 as it says here. So yeah, that's all for this video. Thanks for watching. Bye.